to take a look at some examples of 45, 45, 90 triangles. So let's review that a 45, 45, 90 triangle has sides that are equal length. So we call those x. And then the hypotenuse is always equal to the leg length times the square root of 2. So we'll call that x square root 2. And that's the pattern the sides will always follow. So with number 1, for example, let me grab another color. We have our 45, 45, 90 triangle. And one leg is equal to 9. So automatically we know the other leg must also equal 9. And then the hypotenuse would just simply be 9 square root 2. And that's it. We don't need any extra work to solve those sides. That's the beauty of special right triangles. They save you lots of work and therefore lots of time. So in the next example, they gave you the hypotenuse is 8 square root 2. So that 8 is the length of the leg. So we can just plug it in for the x and the y. And again, no work would be needed there. For number 3, they gave you the hypotenuse is equal to 8. So let's zoom in and focus on this one for a second. Our hypotenuse is equal to the leg times the square root of 2. And so it's not as simple to just pick this one out. We'd have to divide by the square root of 2 to figure out the length of the leg. And then you end up with 8 divided by the square root of 2 equals the length of our leg. But we in math do not leave radicals in the denominator. So we have to force the square root of 2 to come out evenly. So what we can do is multiply it by itself, which then brings it out evenly because it becomes the square root of 4, which just simply equals 2. So therefore, you're able to force it out of that little house or that radical. In the numerator, you just combine what's up at the top. So you have 8 square root 2. But then we have a little bit to simplify after that, because we end up with 8 square root 2 over 2, which we can just simplify to be 4 square root 2. So that type takes a little bit more work, but nothing you can't handle. So each leg is 4 square root 2. But we will notice in some other examples that it always ends up being this same pattern, and then you could just simplify if needed. Let's look at another example. Number 4 gave us the same situation. We have a hypotenuse that's equal to 6. So that's equal to the leg times the square root of 2. So we can just say that the legs are going to equal 6 square root 2 over 2, because I know that the work involved to simplify this equation would be very similar to the last example we just worked out. So let me show you again. If 6 equals the leg times the square root of 2, we'd have to divide by the square root of 2. And then we don't want to leave a radical in the denominator, so we'd have to get rid of it by multiplying it by itself. So then the 2 comes out evenly, and we end up with 6 square root 2 at the top. So notice that works out very similar to that last example right there. And so knowing that, we can kind of skip all that work and just put that in place when we're given that hypotenuse and it's not as easy to pick out. And then we can just simplify a little bit more and get 3 square root 2, because 6 divided by 2 would just be 3. All right, let's look at this last example here. So in this one, you're given the 7 is the only leg you have. So we need to go ahead and fill in that this other leg would be 7, and then this hypotenuse would be 7 square root 2, because that all pertains to that top right triangle that's 45, 45, 90. And now if you look at the bottom triangle, that's this one, you have a leg that is 7 square root 2, so the other leg would have to be 7 square root 2, and the hypotenuse would be 7 square root 2 times the square root of 2, which is 7 square root 4, which is 7 times 2, which gives you 14. So x that they were looking for is just equal to 14. And I think that's the end of our examples for this